to get this building to be a passive house, these developers are already doing what they considered high-quality buildings. If they were going to put an HRV in these units, they put HRVs in all their houses. It's just part of their quality that they consider. A Canadian triple glazed window, a Sirius window, 12-inch double stud wall in this building would be a passive house. These are rough cut numbers because they're not certifying. And we're not fine graining every thermal bridge on these buildings. They love market integrity, these developers. That's what they want to use. They were not comfortable ordering anything they couldn't get from their local lumberyard and get absolute backup. And Marvin hadn't come up with a triple glazed unit. And they decided to do a 10-inch double stud wall, honestly, for pretty arbitrary reasons. I think they just didn't want to do what we recommended, and they wanted to walk us back a notch.
Should have recommended 14 inches.
And next time we will. All right. It's that, I think it was, they didn't run financial analysis. They never showed us the numbers. They just thought they could pull it off, which seems to be how they most of them work. So, 10.19, we're at double the heating energy of a passive house. We're still well under the primary energy, so our total damage is pretty low. And the peak load per unit is 10,000 BTUs per hour. Again, they decided they were putting air conditioning in this building. It was already a given. So there's already a heat pump in the building. So we use it for heating. So we showed them the successful trick of reduce the mechanicals, get it down to an air source heat pump level. The thing they were already going to buy, because usually they put a gas boiler in their buildings and an air source heat pump. But they were clever enough to realize that air source heat pumps were powerful enough, they didn't have to be a passive house to pull that off. And they could get away with double glazed windows, except for the fact as architects we designed plate glass windows around these bedrooms, and I'm totally nervous they're going to be cold because it's cold glass. And then their lumberyard told them that they could save 20 grand on the entire building if they put Anderson 400s in. So, in the end, we're down to an Anderson 400. This is a speculative condo building where they pre-sold 4 of the 7 before they broke ground. It was just amazing to watch. They had zero incentive to do a high-quality building beyond their own pride. And when they saw $20,000 on the table, and they pre-sold them, and no one had asked them about energy efficiency. Their green aura was good enough that these clients only cared about, where's the laundry, what are you doing in the kitchen, what do I have for appliances. So this is what they're building right now, Anderson 400s. And again, but we're still under the primary energy number because they're using little gas heaters for hot water. They've got natural gas on site. This is where this is this interesting story about how these projects evolve, because the financial incentives align for them to do it this way. Last one, gotta be quick, don't I? Blueberry Commons. We just, a month and a half ago, were called in as consultants to another architect in town by the CEO of the largest assisted living complex in southern Maine. So this is their Hilltop Lodge, and around it are dozens of cottages, single-family homes, and they are, sort of upper middle class residents of southern Maine. This is their assisted living place. So here's their lodge. They are building two 14-unit buildings and one 6-unit building, and they're starting construction in January. And they have pre-sold 11 of them. But they own all the buildings, so they are a rental manager. They watch their energy bills come in. They're not speculative at all in that same way. The CEO got the gospel of something. Well, he's always been interested, but somehow he saw something we were doing. He hauls us into the meeting and says, like, green this thing up. Show us what you can do. And it's a totally tough situation because we're not the architect, and the architect's sitting there, and this is what they've drawn. And we're not going to touch it, or else we'll get kicked out of the room. And this is like a classic, I picture this like 128 Woburn apartment buildings. This is a 2x6 fiberglass building on top of a parking garage, some truss, some stick frame, vinyl windows, 135 bucks a square foot. And maybe some ventilation, maybe not. They don't really know. A lot of sound complaints. So here's their plan. 4 units, 2 stair towers, elevator core, stack it up, 1,500 square foot apartments, $450,000. Here's the thermal model of the building. You know, this is the heated envelope. We do our takeoffs this way because it turned out to be faster. We ran some quick analysis. We were like, all right, get a passive house. So this is sort of the bait session, which was, there's about $1,000 a unit in yearly cost hanging out there. They sort of lit up to that. Like, oh, if you do a world-class building, that's how we put it, like best-in-class building, we ran their numbers off their other houses. So we were like, oh, there's maybe $1,000 sitting there. And we go really ludicrously fast. Here's the building they did. This is modeled in PHPP, which is not meant for code buildings. So, you know what, add 50% to this? 25. But we ran a scenario, the code scenarios through that. Peak load, 454,000 BTUs an hour. This is Adam. This is your dorm scenario. And it's bigger than that because it's not a PHPP building. 30,000 BTUs per hour peak load for each apartment. Annual heating, 36. Primary energy, 70. We found out that they were spending $27,000 per unit on mechanical systems. We asked the builder, like, what are you spending? Oh, about 300 grand in this building. 14 units. So, you know, that's when your eyes light up. Like, ooh, we got something to work with here. And I don't know how they're spending $27,000. It's like a gas boiler and air conditioning, and you know, they're just weaving stuff all through the building. We showed 3 scenarios: a low energy building, called it, which is a 10 kBTU per hour building, and a passive house building. And I just want to quickly run through what it takes, and this is blank with Adam. R30 walls, a couple inches of rigid on that 2x6. Code roof, R10 slab, R20 basement walls, and you know, a triple glazed window with decent solar heating. Not changing their design. We didn't touch their design at all. We didn't change their windows. And this building crashes to 10,000 kBTU peak load per unit. We're in heat pump territory. They already are going to put air conditioning in these units because these are high-end folks. You know, so it's just R30, and we are at, you know, how much is it going to cost? We're guessing 15 grand per unit mechanical. We got $12,000, and these apartments have like 20 feet of outside wall. You know, we can improve these things for $10,000.
$27,000 came from the number of square footage by a number of dollars per square foot. Because that's how those people estimate. They don't have a system design.
Yeah.
So that savings is in their budget, but it's not a real number. It's not a real number. They'll spend less on that, and they'll go over somewhere else, and they'll be happy. I think at this stage of that project, they don't really have $27,000.
Yeah, and that's what, and so the dangerous thing is that we exposed to the owner that he was spending 27 grand on a mechanical system for apartment. He's a smart enough guy to say, whoa. You know, so he already smells there's money recaptured in there. This thing's a passive house. This is a 5,000 kBTU peak load on these units. We've gotten this peak load of the mechanical system size down to the Hello Kitty hairdryer. So this is, or you know, more realistic, 2 $50 strips of electric baseboard for this $1,500 apartment. So that can afford a really nice HRV. And they have a maintenance staff that will actually clean the filters through the whole thing. And these are elderly people who don't even take showers, so there's no hot water use. One a week, they said. They take 1 shower a week. And then we had to present these scenarios. And we put numbers to these cost increases. And we're architects, so they're kind of fake, and we're probably going to get in trouble. But you know, this is cost of construction improvements minus cost of mechanical systems all the way down. Monthly payment for the building. This is not ROI. This is not even taking into account inflation or anything. And we're showing that this thing we're calling a low energy building, $87 less a month. And the passive house is $110 less a month. I mean, so it's kind of this amazing territory. I suspect, Mark, it's that there's just this slop built into these mechanical systems that's sitting there as this fruit, sort of ripe for picking. But it's been a really interesting exercise to realize this is without an optimized design. This is us holding our hands behind our back, you know, to think about it. So, but here's the problem: math is actually hard. So we're going to get bitten somewhere along the line. But that's my slide.